Unit 2 Fuel Debris Trial Retrieval. The trial retrieval of fuel debris utilizes a hole, called the X6 penetration, in the primary containment vessel, and it is performed by a device through the penetrated area to conduct an internal investigation and retrieve a sample of fuel debris. The following is a detailed explanation of this procedure and the tasks that have already been completed. Isolation chamber installation. An isolation chamber has been installed in front of the penetration area to prevent the surrounding environment from being affected. It prevents gases inside the primary containment vessel from leaking out. Opening the X6 penetration hatch. A device specifically designed for this purpose was used to open the penetration hatch. It was found that the penetration opening was covered with deposits. Removing deposits from inside the X6 penetration. A low-pressure water deposit removal device was used for this task. A rod called a dozer tool was first used to collapse the deposits. After this, low-pressure water was sprayed on the deposits to remove them, and we were able to see cables at the back. These were used to maintain and manage the reactor, and were stored inside the penetration prior to the accident. Then, the deposit removal device was used to push the deposits using a combination of low and high pressure water to cut the cables and so on by water mixed with abrasives. This process was repeated until all deposits were removed. Internal investigation and trial retrieval. Fuel debris sampling must be successfully and quickly carried out in order to ascertain the attributes of the fuel debris. Therefore, a telescopic retrieval device will be used first, and then an arm-type retrieval device will be employed. Trial retrieval of fuel debris using the telescopic retrieval device. Push pipes were connected to the telescopic retrieval device and inserted into the primary containment vessel. The end jig was passed through the isolation valve to commence the trial retrieval of fuel debris. Having accessed the pedestal, the end jig on the telescopic device was then lowered to grasp fuel debris. After the end jig was hoisted up, the guide pipe and the end jig were withdrawn back inside the enclosure. A dosimeter was used to measure the dose of the fuel debris from outside the enclosure, and it was confirmed that the dose was less than 24 millisieverts per hour at a distance of 20 centimeters, which is the criteria for determining whether or not to proceed with fuel debris retrieval. Having confirmed that it was safe to proceed, the fuel debris was successfully stored in a transportation box and removed from the side hatch, thus marking the completion of the trial retrieval. The mass of the sampled fuel debris was measured inside a glove box, after which it was put into a box. The box was removed from the glove box while simultaneously putting it into a plastic bag to prevent the spread of contamination, and then inserted into an off-site transportation container. The off-site transportation container was then loaded onto a transfer vehicle and taken to the JAEA research facility in Ibaraki Prefecture. The analysis will focus on ascertaining the attributes of the fuel debris, and the data obtained will be used to deliberate how to prevent worker exposure and criticality during the course of retrieval in the future. Fuel debris retrieval is being carried out step by step, and we plan to gradually enlarge the scale of retrieval. We will continually subject the fuel debris that will be retrieved in the future to analysis, and use the resulting information to improve fuel debris retrieval methods and safety measures, and deliberate storage methods. Internal investigation and trial retrieval using the ARM-type retrieval device. The retrieval device will be replaced with an ARM-type device that will be used to construct an access route, after which an internal investigation and trial retrieval will commence. Checking for any impact on the surrounding environment. Before and after the series of retrieval steps, no significant fluctuation was seen in monitoring post or dust monitor data, and no significant fluctuation was seen in plant parameters during the investigation. Thus, there has been no change to cold shutdown status. While conducting the whole trial fuel debris retrieval process, we will continue to constantly check that there is no impact from radiation on the surrounding environment. Various types of such data will continue to be disclosed on our website.